In today's lesson, we are going to be doing some work with the equations for parallel and perpendicular lines. We're going to start by looking at a graph of three lines that you can see drawn here. We're going to start by writing the equations for these three lines in slope-intercept form. So slope-intercept form is y equals mx plus b. So starting with this first line here at the top, notice that it has a y-intercept of 6, so that's what we're going to plug in for b. And if we look at the slope to get from one point to the next perfect point, it looks like we're going up 2 spaces and over 1 to the right. It's increasing as we go from left to right, so it has a positive slope. And up 2 over 1, 2 over 1 is just the same thing as 2. So it has a slope of 2, positive 2, and a y-intercept of 6. The second line has a y-intercept of 2. And if we look at the slope to the next point on that line, it looks like it's the same. Up 2 over 1, 2 over 1 is the same thing as 2. So this one has a slope of 2 and a y-intercept of 2. And our last line has a y-intercept of negative 4. To get to the next point, it's the same slope, up 2 over 1. So that equation is 2x minus 4. So the thing about these three lines are that they are parallel. A definition for parallel lines is that they never cross. We can see that they have exactly the same steepness, which in the equation shows that they have exactly the same slope. Remember, slope describes the steepness of the line. So the slopes of parallel lines are the same. And that's what makes it so that they never cross. Write the equation of the line parallel to y equals 3x minus 2 and passing through the point 2, 9 in point slope form. So first of all, if our line is parallel to this line, that means that it's going to have the same slope of 3. Now, what I'd like you to do is cross out that minus 2. That does not matter to us. We don't care what the y-intercept of that other line is. We're not going to do anything with that in our final answer. So the only thing we're going to get from that first part is just that our slope is 3. Then we know a point that it's passing through. So we can call that x1, y1, because our final answer is going to be in point slope form. So remember, point slope form from the previous lesson is y minus y1 equals m times the quantity x minus x1. We'll want to have that formula memorized. So our final answer is y minus 9, the 9 came from the point over here, equals 3, that's our slope, times the quantity x minus 2, and the 2 also came from that point that it was passing through. The next question says to write the equation of the line parallel to y equals negative 5x plus 1. This time it passes through the point 7, negative 3, but now our final answer is going to be in slope-intercept form. So here's another example of where we want to pay close attention to what form the question is asking for. So going back to the beginning, if it's parallel to this line, it just means that our line is going to have the same slope. So our line is going to have a slope of negative 5. We don't need to do anything with that plus 1. It doesn't mean anything to us, so we'll go ahead and cross it out. Passes through the point 7, negative 3. Now, to get this into slope-intercept form, we're going to start by putting it in point slope form, and then we're just going to go with the additional step to turn it into slope-intercept form. So this one is going to be y minus negative 3, which is really y plus 3, equals negative 5 times the quantity x minus 1. Now we're not done yet because we want to get it in the form of y equals mx plus b. We want to get y by itself. So let's go ahead and distribute the negative 5. And then we're simply going to subtract 3 from both sides. So our final answer here is y equals negative 5x plus 32, because it's asking for the answer in slope-intercept form. Determine whether or not the following pair of lines are parallel. Well, we can see if they're parallel if they have the same slope. The second equation is already in slope-intercept form, so we can see that it has a slope of -3/5. Let's do some work with the first equation. So I'm going to rewrite this off to the side. We're going to need to do a few steps to get y by itself, so let's start by adding 5x to both sides. So that'll look like this, 3y equals positive 5x plus 9. Then to get y by itself, we're going to divide everything on both sides by 3. So we have y equals 5/3 x plus 3. Notice how this one has a slope of 5/3. Although that looks similar to -3/5, they both involve a 3 and a 5, they are not parallel because their slopes were not the same. The slopes, however, do have a relationship that we're going to be coming back to and talking about in a few minutes. Now it's time to take a look at a new graph. We have two lines here. We're going to write the equations for each line in slope-intercept form. So let's start with this line here. Notice that this has a y-intercept of 1. And the next point here, if we go up 2 spaces over 1, it looks like we have a slope of +2. So we have y equals 2x plus 1 for the first line. Now the second line has a y-intercept of -4, and to get from one point to the next point, we're going to go up 1 space, and then we're going over 2 spaces to the left. So up 1 over 2 means that our slope is going to have something to do with the fraction 1/2, but because this line is decreasing as we go from left to right, that means that the slope is negative. So it's -1/2 x, and then our y-intercept was -4. So the relationship between the two lines I gave you here is that they are perpendicular. Perpendicular lines form a 90-degree angle. So this angle right here is 90 degrees. That's also called a right angle. And the connection between their slopes is that they are negative reciprocals. So if we take a closer look at the two slopes side by side, that +2 is the same thing as 2 over 1. If we take the reciprocal of that, make it 1 over 2, and put a negative sign in front, we get the other slope. So that's the relationship between the slopes of lines that are perpendicular. Take the reciprocal, one is positive and one is negative. So actually what's interesting is that if we go back to the previous problem where we had a slope of -3/5 and +5/3, those are negative reciprocals. One's positive, one's negative. We've got 3/5 and 5/3. So although these lines are not parallel, they are actually perpendicular. So we're going to think about negative reciprocals to help us now with a few problems involving perpendicular lines. To find the negative reciprocal of the following slopes, we're going to first just take the reciprocal and then put a negative sign in front. So 1/2 and -2 are negative reciprocals. Now let's look at the next one. -5 is the same as -5 over 1. If we do the reciprocal, flip the fraction, it turns into 1/5. It already has a negative sign in front. So if you think about putting another negative in front of the negative that's already there, it's going to make it positive. We don't actually need to write the little plus sign there, but we'll just keep it as positive 1/5 is technically the negative reciprocal of -5. For the last one here, the negative reciprocal of -3/4 is positive 4/3. So another way to remember this is that between the two slopes that are perpendicular, you always have one that's positive and one that's negative. All right, so we're going to write the equation of the line perpendicular to y equals -1/3 x plus 7 and passes through the point -2, 5, and we're going to write the answer in point slope form. So the first thing we're going to look at is that it's perpendicular to this line. the negative reciprocal of negative 1/3 is positive 3 over 1. So that's our slope. We don't need to do anything with that plus 7. Just cross it out. It doesn't mean anything for our problem. So we know that our slope is positive 3, and it goes through the point negative 2, 5. We'll use that as x1, y1. So because we're doing this in point slope form, our final answer is y minus 5 equals 3, that's our slope, times the quantity x plus 2. Write the equation of the line perpendicular to y equals 4x plus 6 and passes through the point 3, 1. This time we're going to write the answer in slope-intercept form. All right, so let's start by looking at the equation they gave us. The slope of that line is 4. So our slope is perpendicular. It's going to be the negative reciprocal. So the reciprocal of 4 over 1 is 1 over 4, and we're going to make it negative. Cross out that plus 6. We don't need to do anything with that. All right, so the point that it passes through, we'll call that x1, y1, because first we're going to put it in point slope form. So point slope form is y minus 1 equals negative 1/4 times the quantity x minus 3. But then we're going to do some work to get it into slope-intercept form. We're going to start by distributing the negative 1/4. So we get negative 1/4 x, and then a negative times a negative is a positive. 3 is the same as 3 over 1. Multiply across the top, and then multiply across the bottom. So that just becomes 3/4. Then we're going to get y by itself by adding 1 to both sides. So I'm actually going to write this as plus 3/4 plus 1. We're going to get a common denominator here to add the 3/4 to the 1. So 1 is actually the same as 1 over 1. And to get the denominators the same, we'll go ahead and multiply the top and bottom here by 4. So it's actually the same thing as 4 over 4. So 3/4 plus 4/4, we're going to add across the numerator to get 7 and keep our denominator the same. Let's go ahead and bring the rest of this down. So we have y equals negative 1/4 x plus 7/4, and that is our final answer in slope-intercept form. So the big takeaways for today's lesson are that parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals, and that's just some more information that can help us do work with linear functions.